Hello guys, welcome back. And so today's class I will take a chapter called Water. I have done Merchant of Venice up to Act 3, Scene 1. Okay, watch that if you haven't yet. Or if you come for seeing this chapter, okay, it's okay. I have also done Java programming few videos. Now I have completed one chapter of chemistry called as what we call chemical changes and reaction as two parts, and language of chemistry I haven't taken because since it is we have already know the basics of chemistry. Second point thing is that we have already learned those things about in 7th standard, 8th standard, and also we also know about it. If I get time at last, I will do it. Now no time, that's why I'm doing like this. Okay, so I will take this chapter as two parts, and this is the first part. In first part, I will take these topics up to here. So today's video we will learn what is solvent, solute, and solution. Sorry, I have repeated the solvent two times. I mean solution. Next, dilute and concentrated solution, saturated and unsaturated solution. Also, we learn about solubility and solubility curve. Okay. Since it is only for topic, but little bit we have to learn about. You already know few things about it, and there are few things extra also. Okay, so let's start the chapter. So I've also given a schedule of my next 6 videos. I will be uploading on night or morning as usual. I will upload videos in afternoon. Next, I will take a chapter called next video in 16. I will take conditional statement in Java. I will do this chapter in 3 parts because we have programs to do. Yes. Then on 18th, I will take second part of this chapter called water. 21st, I will take the second part of the Java, and from on 18th we will complete the chapter water, and on 23rd I will take atomic structure and chemical bonding. I will do this chapter as also two parts. 25th I will complete the conditional statement in Java, and in 20th we will also complete atomic structure. So this month we will complete two chapter in chemistry, one chapter in Java, okay, in just a bit of 20 days. Now let's start the chapter. First, we have to learn water. Water is very. What is it? Water. Let us know basics about water. Water, we know it's a liquid state. That is, if you take human body, 70% of the human body is filled with water. Now you cannot live without water. Even I'm thirsty now, but I'm doing a video, so we need water to remove the thirst. So this water, what is this chemical formula? Very good. H2O. That is, it is made up of hydrogen, it is made up of what? Oxygen. So this water is known as a universal solvent. Okay, so you can see the blue letters. So blue letter indicate that these words are what? Important words. And red color is referred to use this red color solute solvent. It is the definition term, important terms. Okay, so why is water called as a universal solvent? That's the first thing about the chapter. In your textbook there is intro about water. We don't need that things. Okay, straight to solute solvent and solution. That's our syllabus of 2021 C's board 2021 board exams for 9th standard. Why is water called as universal? Because water has the ability to dissolve a large number of substances. For example, you take up the water. Let me say this is water. This is water. Now I will take few salt and insert it in it, and I will use a spoon to stir it. What happens? It will dissolve it. Now it forms a solution. If you use salt, you will get sodium chloride solution. Yes, so like salt, sugars, and even gases like hydrogen, ammonia, and so on. So these gases, if you try to dissolve in water, it will dissolve. Not only these substances, it can dissolve a large number of substances. Okay, these words, if you write definition in exam, these words are very important. Okay, and these are most of the common substances. Okay, and that is why water is called universal solvent. Alright. That is why water is called as a universal solvent. Next, we have to learn what is solvent, what is solute, and what is solution. Solvent. Now for that I'll have to draw a diagram or something. Use black ink for that. Now I have a beaker. Okay, now we will learn what is solute. Solute, the medium of dissolution. So medium of dissolution that allows substance which allows that allows a substance which allows solute to dissolve in it is called as a salt. For example, water. Very good example. Water is called as a solvent. So why is water called as a solvent? So this, let me name this as water. Because water allows certain salt to dissolve in it. That is what water is called as a universal solvent. If you don't know what is a solvent, look at this. Water solvent. So this term, water as a universal solvent, states that water is a solvent. Okay. If you forget example of solvent, just remember water as a universal solvent. Got it? So it allows some certain salt, certain sugar, certain gases we have discussed first. That is why it is called as a universal solvent. Now, what is a solute? Substance which dissolve or disappear in solvent. Dissolve or disappear in solvent to form a solution. That is, if you take sodium chloride, if I insert sodium chloride in a solute, that is, it can mix with the water and it becomes a solution. So these salt which I used to dissolve or disappear is solvent so that it can become a solution is known as what? Solute. Solvent, just think about liquid. Solute is just a solid. And if you take solute plus solvent, you will get one solution. A homogeneous mixture of a solute in a solvent is called as a solution. For example, we use sodium chloride. We also took water. If we stir it together, we will get what? Sodium chloride solution. NaCl solution. Sodium chloride solution. Okay. So and just not need to study this equation. I just said sodium chloride solution is an example of a solution. Okay, hope you got this page very well. Now, a very good diagram I have given. So that is, this is called as what? Solute. This is our, sorry guys, wait here. This is called as solute. This water, or okay, it looks like a water. It might be a chemical experiment. So this is known as a solvent. This is called as what? Stir it with the help of a spoon like structure and he got like this. So this is known as what? Solution. Or you can say solute plus solvent gives what? Solution. Got it? Next we have to learn about a dilute and concentrated solution. What do you mean by dilute solution? We have heard dilute hydrochloric acid. What is dilute hydrochloric acid? Concentrated sulfuric acid. What are all these? CONC means concentrated, short form of concentrated. While we write chemical reaction, we use CONC for concentrated. So dilute solute means a solution. It's a solution. We know it's a solution. For example, let me take hydrogen chloride or sulfuric acid. So, or let me take hydrogen chloride. So, if you take the hydrogen chloride, the amount of solute must be relatively very small when you compare with amount of solvent. That is, what is a solvent? If you take water, if the amount of water is low, the amount of the amount of salt is relatively small when you compare to water, then that solution is said to be a dilute solution. That is, if I take this liquid now, I insert 10 gram of salt, salt or sodium chloride and 100 gram of water, which is bigger. Yeah, water is bigger. 100 grams of water. It means what? Let me take 1 kilogram. That means 1,000 grams of water. 1 kilogram. That means solvent is actually large, and this solute is actually low. Then this solution is said to be what? Dilute solution. But what if I take a 10 kilogram of sorry? Let me just let me take a razor. Now, if I want to make this solution a concentrated, what should I do? a very little water. Let me say it is 5 gram of water. In 5 gram of water, I injected 20 gram of sodium chloride. That means amount of solute is actually relatively large when you compare with solvent in a particular mass. And that type of solution is said to be what? Concentrated solution. Okay, just think like this: little sodium chloride, large water is dilute solution. More sodium chloride, little bit water is a concentrated solution. Okay. Dilute, we usually we write dilute hydrochloric acid or DIN HCl, means dilute. Concentrated sulfuric acid, CuNC H2SO. You know, it is difficult to write. I am writing using a mouse. I am writing and explaining you with the help of a mouse. Okay, that's why I find difficulty because I want to mouse. Now we will learn about saturated and unsaturated solution. Now saturated solution. Okay, saturated solution are those solutions which cannot dissolve more of the solute at a given temperature. Okay, that is, if I take, let me take previous example itself, a beaker, water. This is water. This is any type of solvent. Now in this solvent, I try to add a salt. Okay, but when I add this, first 20 gram of solvent it get dissolved. But if I add 15 more gram, it doesn't dissolve due to some reason at a particular temperature. So anyway, that's a solution. So that solution is said to be what? Saturated solution. Then what would be unsaturated solution? Very good. If you add more and more and more solvent, it gets dissolved. So those are known as unsaturated. That is, if it cannot dissolve more solute at given temperature, it is saturated. The vice versa is unsaturated. In next time, don't write vice versa. In next time, you have to write a solution in which it can dissolve more and more of the solutes at a particular or given temperature is known as unsaturated solution. Like the fourth sentence, and vice versa is called unsaturated. That's wrong. Okay, I just made you clear for understanding. Okay. This saturated solution, you can convert that to unsaturated solution by two methods. Saturated solution, that is, suppose you cannot add 15 gram of solvent, but you need to add. That means you have to convert the saturated to unsaturated. It can be used by two methods. Number one is to heating the saturated solution slowly. First of all, give a low temperature. Suppose you used a Bunsen burner, first supply 10, then supply 15, then supply 20 slowly. If it does that, what happens? It dissolves more of the solute at higher temperature. Or you have to add more solvent. That is, let me just make you understand. Okay, so now let me just draw a simple figure. That is, I used a beaker, water. Now I add a salt. I add a salt. Okay, first of all, I add 20 gram of salt. It dissolved it. Now I need to have 30 more gram to finish some of my experiment, but it doesn't. Now what will we do? Now let us consider the amount of water is 100 grams of water. That is, if I add more and more water, what happened? It just converts to unsaturated solution. That is, I will make up to this level. That is, let me tell it is 500 grams of water or half kilogram of water. Then it can dissolve more and more solvent. So you can either heat it or you can add more and more solvent to make it unsaturated solution. Okay, so look at this. This is saturated solution and that is unsaturated solution. Okay, if you use these two techniques, you can convert saturated to unsaturated solution. Look here, it cannot dissolve more and more substances. It cannot, but this can actually dissolve more and more substances. Okay, you can convert it. Okay, that is, you can either heat this or you can either increase the amount of solvent or liquid. Now, we have discussed only about water. Now we will discuss about other solvent like benzene, petrol, and the soluble dissolve. If you take benzene and petrol, it get dissolved in rubber. Tubertine oil, what happened? It get dissolved in paint. Oxalic acid, and rust is very important and commonly asked questions in examination. And acetone, a very good example. Acetone also nail polish and methyl spirit chlorophyll. In the textbook, there are few examples given. Okay, so we have to study them. And solubility and solubility curve, very important topic. Now first let us cover what is solubility, then only we will come to what solubility curve. Solubility means solubility of a solute in a salt. What do you mean by that? At a particular temperature means the maximum amount of solute in gram that will saturate 100 gram of solute. That is, if I take a beaker and 100 gram of water, let me say just 100 gram of any solvent, what we use commonly water, 100 gram of water, and I added 80 of salt. I add 80 gram of salt. That is, that means this is the solubility. That is, in 100 gram of water, the maximum amount of solute I can add in gram is known as the solubility of a solvent at a particular temperature. That is very important. Okay, that means what is the solubility of this diagram? Yeah, in 100 gram of water, I am able to add 80 gram of salt. This is just an example. I don't know whether it is not 80 gram. I just given some amount of salt. Okay, while performing experiment, we don't have any experiment. You will understand what is its solubility. And what do you mean by solubility graph or solubility curve? Solubility curve is also known as solubility graph. It means a graph showing effect of temperature on solubility of substance. Effect of temperature on solubility of substance. Suppose if I get 30 degrees Celsius, if this it is effect of this temperature on some salt and on some salt. We will learn solubility curve in detail. Okay, at a particular temperature, effect of temperature on solubility of a substance. That's known as solubility curve. That is this one. This is solubility curve. Ki, potassium iodide, NaNO3. Not all we have to learn, just a bit of few. Okay. Now let's. First one is KNO3. That is this one. KNO3. Potassium nitrate solubility increases with increased temperature. Okay. This this is temperature in degrees Celsius, and this is our what solubility in gram, solubility in gram. So that is solubility in potassium nitrate increases with increase. Look, if you take a closer look, let me just zoom in. Look, KNO3. That is, it is in 15. So 15 gram of solute reaches where 150 gram of solute. That is, what is the effect of temperature? The potassium nitrate was in 0 degrees Celsius. On reaching 150 gram, what happened? Yeah, it reached 60 degrees Celsius. Got it? You know how to look graph. Yes, not learned in maths. Look, that means it reached what? 70 degrees Celsius. Okay, not 70, 60, 65 degrees Celsius. That is what. Okay, that is what this graph says. Secondly, sodium chloride. Sodium chloride. Let me check where sodium chloride. Yeah, is in a straight line, like a straight line with sodium chloride. So if you observe sodium chloride, solubility increases slightly. This word slightly is very important. If you don't write the word slightly, your mark is gone. So slightly, look at this. It was a 30 gram of sodium chloride. Okay, it was sorry, 30, or consider it as 40 gram. Look, 40 gram, 38 gram. Okay, it is not 40, it is 38, 37 gram of sodium chloride. When it reach 40 gram of sodium chloride, what is the effect of temperature? It's slightly increased. There is just slightly increased. If you observe this graph, it was here, but here it is here. That means a slight growth. That is, if you take this, it's slightly increased like this. That is a motion. Third one is CaSO4, calcium sulfate. Solubility decreases with rise in temperature. Where is CaSO4? Okay, there is no CSO for what I think. That is, the solubility decreases with decrease in temperature. That is, it might, suppose if I take 50 gram, the temperature might decrease and go like this. Okay, not this much, not this much, but it means slightly, slight decrease, or it just decrease like this. Okay, okay. I cannot draw it properly. I'm sorry for that. Next is Na2SO4 10H2O. So it shows solubility in sharp break at 36 degrees Celsius. That is, it is in hydrous state. Hydrous, what do you mean by hydrous? We will learn later. That is why it is dot NH2 is there, because it is hydrous. So at the sharp 36 degrees Celsius, what happened? It becomes anhydrous above that temperature. Okay. What do you what do you mean by that? At 36 degrees Celsius, at 36 degrees Celsius, it shows solubility at hydrous state. Hydrous state. But when it is 36 plus degree, that is, if it is above 36 degree, it becomes anhydrous state. We will learn about hydrated and anhydrated in detail. Hydrated, that hydrous means water molecules are present, but anhydrous doesn't contain. Okay. Next, that is about solubility curve. Now, thank you guys for watching this. We have completed our aim. So, like the video, please share with your friends so that I can increase views and subscribe the channel. I will see you guys in the next video. Stay safe, stay healthy, take care. Okay, also maximum share with your friends. Maximum share and share and share and share and share. And tell your friend also to share. In second part, we will take crystallization, and WOC means water of crystallization, hydrated and anhydrous substances, efflorescent deliquescence and hygroscopic substances, and drying and dehydrating agent. So that's all. So see you guys in the next one. Till then.